So welcome everyone to week one of Space Science with Spice. My goal for this lecture is to teach you how to code with a language called Python and some associated libraries in a physics context. And as always, I've broken the lecture up into 5 sections. The timestamps for each of which and related links are in the description if you want to skip around. And another little tip is that at the start of every section, I'm going to tell you if you have the prerequisite knowledge to skip or speed through the section. You'll see what I mean in a few seconds. And on a more general note, as we begin actually learning stuff, at first trying to absorb all these new concepts may feel like trying to drink from a fire hose, to borrow a phrase from MIT. But be assured that if you really stick with it, after a few weeks you'll be confident in your ability to learn and apply these concepts. And if you don't know me, hi, I'm Zane. You can find my email and Discord in the description. Message me if you need help with anything for this club or school in general, or if you just want to chat. I'm always happy to talk. So now we'll start with part one, which will be an introduction to computer science. On the prerequisites, if you used a programming language before, consider skipping this, although I'd still recommend you watch to gain a more conceptual understanding of the topic, or at least the terminologies I'll be using. Now, computer science is a huge field that's exploded over the past few decades, but fundamentally, it's really just problem solving. We can think of problem solving as the process of taking some input, which will be the details about a problem, and generating some output, which will be the solution to our problem. And this proverbial black box in the middle is computer science, or the code we'll learn to write. Now, programming itself, or coding, just means giving a set of step-by-step instructions, or algorithms, to a computer to execute and solve a problem. If you've ever cooked using a recipe before, you can think of yourself as the computer and the recipe's author as the programmer. The recipe author provides you with a set of instructions which you read and then follow. The more complex the instructions, the more complex the result. So here's an example of an algorithm, or again a set of step-by-step instructions, for finding a name in an alphabetized phone book. Going in order of the lines, we'd open the book to the middle, decide whether our name will be in the left half or the right half of the phone book, since again it's alphabetized, and then reduce the size of our problem by half by discarding the section where we know our name won't be. We can repeat this until we find our name, dividing the problem in half each time. So with 1,024 pages to start, for example, we would only need 10 steps of dividing in half before we have just one page remaining to check. Now this algorithm is written in something called pseudocode, literally meaning fake code, which is a representation of our algorithm in precise English. And although computers don't actually understand pseudocode, it's really, really important to conceptually understand the distinct parts of pseudocode before looking at the actual syntax of a programming language, because these rules that I'm about to tell you will likely apply to every single language you'll come across. So if we look at the bolded words, or sorry, the highlighted words from the phone book search algorithm, we'll see that some of these lines start with the verbs or actions like pick up, open to, look at, and we'll call these functions. We also have branches that lead to different paths, all these if, else if, and else statements. And these are like forks in the road, which we'll call conditions. Um, and the questions that decide where we go are called Boolean expressions, which eventually result in a value of yes or no, true or false. So is this person on this page? Yes or no. If yes, then call them. Is this person earlier in the book? Yes or no. If yes, or if true, then open to the middle of the book, and so on. And lastly, we have words that create cycles, and this is where we could repeat parts of our program called loops. Just as a general note, in computer science, this process of simplifying a really complex concept like searching a phone book is called abstraction. So part two is going to be coding in a language. In our case, this will be Python. And the prerequisite to skip this is if you're already comfortable with Python, you could skip this entire section. Or if you've already taken AP Computer Science A with Java, then I'd recommend watching the first 14 minutes of the video I've linked in the description called Learn Python in 60 Minutes from Java. And I've also linked my own notes on the video, which is kind of like a Java to Python cheat sheet, and I still use that today. So we just looked at pseudocode, which is a representation of our algorithm in precise English, but computers don't understand English. They quote-unquote think in binary, which are strings of ones and zeros. And this is where programming languages come in and allow us humans to translate our instructions into a language that computers can understand. So there are many different programming languages, actually, now that I think of it, including one that's actually entirely made of emojis. I'll link it in the description if anyone is interested. But we'll be using something called Python, which is a really versatile and beginner-friendly general-purpose programming language that can be used in a huge variety of fields. And as a bonus, it's also the most popular programming language according to GitHub's popularity index. I'll link that below too. So you do well by getting a head start and learning it right now. So right now we're just going to look at the actual syntax or the structured language of Python, and the link to this is going to be in the description. Alright, so on that link, we're going to be using this platform called Google Colab, which is really similar to Google Docs, except for it's for coding. You can have a mix of blocks of code and text. Oh, there's a cat up here. It's really distracting. Sorry. You can use it by expanding these sections and then running the code or clicking the play button in these code segments to run them. I'd highly recommend making a copy of this collab so you can both, one, tinker with the code, which is one of the effective ways to learn how to code, and two, use this as kind of like a cheat sheet or like a set of notes to add on to and modify as you learn Python. And trust me, this is going to serve you really well if you decide to pick up Python again after a few months if you take a break. I'd also recommend these two resources I've linked right here, or really anything else you find online, because remember, you don't have to memorize or even read these entire two documents. This is the reason I'm pre-recording these lectures too. In the future, whenever you come across something you don't understand in like future lectures, you can pause the video and use this Colab or some other online resource, because the point isn't to memorize code, it's to understand like why we're using this and the structures behind it. So we can jump right into, we're going to start with the basics of Python. So at the very beginning, we start with variables, which basically allow you to store different types of values. So Python, like most programming languages, supports different types of variables called data types, including integers, which are whole numbers, floating point numbers, which are decimals, booleans, which are true or false, we'll get into this later, and strings, which are just text. You don't need to specify the data type of a variable, unlike a language like Java. You can simply assign any value to the variable, and Python figures the rest out. And you assign it using this statement, where you'd say the name of the variable is equal to the value you wanted to assign it to. So for example, if you want to make a variable x equals 3, Python is going to assume it's an integer. But if you assign x is equal to 3.5, then Python already knows it's not an integer, but a floating point number. And on naming your variables, the name can be any combination of letters and underscores, and it is case sensitive. Now, we can do all we want with our variables and our operations, but we need a way to see some output of our code. And the way that we're going to do that is with the print function. And that's just going to be the word print, and in between parentheses, we're going to put either a value or a variable, whatever you want, and that's going to output it's going to output whatever you put there. So we could start with this little sample bit of code. This is going to be for assigning and printing variables. So at the beginning, we're going to have our print statement. We're just going to print this string, hello world. And we'll just run the code and see what happens. Hello world. Yeah, we see that. And then past that, we make a variable called month, and we assign it the string February. We make a variable called date and assign it the integer 24. And so we're going to print as a string today is, and then we're going to use this plus operator, which is called concatenation, which basically just means we're going to add strings back to back to back. So today is month, but the output isn't today's month, it's the month of variable, so it's going to see, and the month variable is February, so today is February, and I add a little space here, and then day to string. Basically that just makes it so Python doesn't have to add a number, it knows, okay, it wants us to print like 24 as text. And so we're going to get hello world, today is February 24th. For the sake of versatility, here's another way to print and swap the values of variables. So this program, x is 1, y is 2. We have our print function, we have an f, and then we have these curly braces, and then the value for our variable here. And if we run this function, we'll see, so x is equal to 1, and then y is equal to 2. And then we have this other way of assigning variables. So this looks a bit confusing, but really all this is saying is that we have the first value that we want to assign, the second value we want to assign, this first one goes to the first one here, and the second one goes to the second one here. So the value of x becomes the value of y, the value of y becomes the value of x. And these happen at the same time. It's not like x becomes y and then y becomes y, because x is already, you don't have to worry about that. It's going to happen at the same exact time because it's on the same exact line. And as you see, we run the same print statement that we did up here, but this time the values of x and y are switched. So this is something to just keep in the back of your head. You don't need to memorize this. Now we'll move on to operations. So what's really good for us, this being a physics-based club, is that you could do math with Python. We have the basic 4 operations of PEMDAS in order of precedence, with the modulus operator, which basically finds the remainder of a division operator on the same level as multiplication and division. So just parentheses comes first, exponentiation is these two stars. asterisks, and then we have our multiplication, addition, subtraction. So here's a bit of sample code for mathematical operations. I recommend you pause for a second and understand why each of these outputs that ends up showing up, why these are here. You'll see we have 5 plus 2, especially this one on line 4. If you saw this in a math class, you'd think that x is equal to 2x, so x equals 0. But with coding, it's a bit different. Basically, what you're doing is that you're taking the value of x, which is 7. You're always doing the right side first. So this would be 7 plus 7 equals 14. And then you're kind of dumping that into this variable x. And this variable x takes on a new value, which ends up being 14. We just have a bunch of print statements. We have multiplication, division, exponentiation, and modulus. We see all of these printed here. So again, pause this and look over and make sure you understand all of these. So now we can move on to control structures. So a program sometimes, of course, has to make choices, and these choices can execute different bits of code depending on whether or not a certain condition is true or false. Usually if it's true, then it's going to execute it. So we have these comparison operators, which is equality, greater than or greater than equal to is this, smaller than or smaller than equal to is this, and not equal to is this. Notice how when we're testing two things for equality, so we're going to have something before and something afterwards, and if they're equal, then it's going to return true. Let's say we did is 5 greater than 3, it's going to return true, but if we did 3 greater than 5, then it's going to return false. And that's basically how these comparison operators take two values and it yields a Boolean value, depending on whether or not the expression or the thing that you've written out is true or false. Conditions can also be combined with these phrases, and if there's a long string of them, this is the order of precedence, not, and, then or. And the function of these is pretty self-explanatory. Not turns a true into a false, and returns true if both conditions are true. So true and true is true, true and false is false, because of course and means both of them have to be true in order to return true, false otherwise, and or returns true if at least one of the conditions is true. So yeah, we could look at an example right here. Here's the general structure of it. You're basically going to have your if condition and then your statement here. Always your statement, what you want to have within the if statement is indented. And we could have multiple statements here as long as they're all indented. And the indent lets Python know that these are going to be under the same if condition. Notice that we have one if, there's always one if and one else, and then these elif stands for else ifs, and we can have multiple of those in between the if and the else. So it's basically the computer as it runs through this, it's going to think, okay, if this condition is true, then we're going to run this, and then we're going to skip over the rest of them. But if this isn't true, then we're going to check the next one. So if this isn't true, well, else if this one is true, then it's going to run this, and it's going to check all of them until it gets to else. And if else isn't, or if all of these are false, then it's just going to run the else statement. Regardless, it doesn't check anything with the else statement. And if there's no else statement, then it's just going to end it and it's not going to execute any of these statements. So we could look at a sample program right here to see how this kind of works. And I really recommend, again, making a copy of this Colab and playing around with these values to see if you could get each of these print statements to show up. So here's an example of how the ands and nots take place. So again, I'll go through kind of how the computer would think about this. You have a is equal to 3 and b is equal to false. So if a is greater than 0, so 3 is greater than 0, that's true. So we can, the computer's thinking, okay, this is true. Then we see and, which means, okay, in order for this to return true and run this, then this has to be true and this has to be true, therefore this would run. So we check not b, well b is false, so not b would return true. So then we have true, and if you remember, if both of them are true and it's an and, then and will return true, and then as we can see, if we run this, then it does return this, it is true. Again, I'd recommend you play around with these values and see if a mod 2 is equal to 0, which basically just means if it's even, if 1 divided by 2, the remainder is 0, or b, in this case b would have to be true, and that we can see this reflected in the print statements. And I have a couple of exercises right here in the comments. Again, make a copy of this and try and solve these, show them to me whenever you finish, or if you need help with any of them, I'd be happy to help. Of course, I'll always say this every single lecture, the best way to learn how to code is to actually code it yourself. So make sure, try and put these ideas to the road and try and apply them and try and write your own code. So we're moving on to loops now. While loops will basically repeat code until this condition right here, and this is the general structure, while condition statement. It's going to repeat the statement until the condition becomes false. So it's going to check while condition. If the condition is true, then it's going to execute this, and then it's going to loop back, and then it's going to check if the condition is true, then it's going to do the statement again. So this can go on forever, but it doesn't necessarily have to. So we could see here, here's a sample code. So if we set x equal to 3, while x is less than 10, then it's going to print x, and then it's going to increment 1. So just walking through how the computer go through this, x is equal to 3, so it's going to check while, so this is the condition, x is less than 3, well x is less than 10, it's going to check, well x is 3, so is 3 less than 10? Yes, that's true. So we're going to run through this, we're going to print the number, and then we're going to do the right side first, just the way that variable assignment works is that we're going to do the right side first. 3 plus 1 is 4, and then x becomes 4. So now the x value in the computer's memory is 4. So now we're going to loop back to the while statement. We're going to go while x is less than 10. Well, x is now 4. 4 is less than 10. That's true. So we're going to execute this, and it's going to go on and on and on. And if we run the code, then we're going to say, yep, it starts at 3, then it prints out 4, 5, and it increments until it gets to 9. And that's because once we get to 9, 9 is less than 10, true, print 9. X is equal to 9 plus 1, so x is equal to 10, and then it comes back here, checks, while 10 is less than 10, well 10 is not less than 10, that's false, and then it breaks out of the code and the program ends. And then here's a quick exercise, predict the effects if we switch the 5th and 6th lines of code, and then test it out. Predict it first, and then switch the code itself, and then test it. And just something to be wary of infinite loops. Right here I'm incrementing it, and eventually if we keep adding 3 to 1 it's going to be more than 10, but you never do this. But if it's always true, I'll cancel this quickly, but you're going to get infinite else statements, and I'll stop this before it crashes my computer. Cool, okay. So just be wary of this. This is an infinite loop, and the computer isn't going to point this out. You have to be able to, once you run your code, it's going to run forever, and you're not going to know. Sometimes you want that because you could terminate the program, but better to not have that and have it terminate at some point. So now we have our for loops, and a for loop is like a while loop in that it repeats some section of code until a condition it repeats some section of code until a condition is met. Yeah, but the number of repeats, or I'll call them iterations, is usually known, although we still can run into infinite loops. Sorry. So we have our general structures. This looks like a lot, but that's just because we have 3 different types of structures. Because the range function takes in multiple inputs or arguments. So with our first one, we just have for our variable, this could be any variable I, let's say, and that's just so we could reference it later. We have our counter here. In our while loop, our counter was x, and we reference that in our code. Here, for a for, we'll still have our counter. This could be x, this could be I. I usually use I, and that could be referenced in your statement, in your indented statements. So we're just going to have some variable range. So when you just put one input into the range function, it's going to start with your variable equal to 0, and then it's going to go up to, it's going to go right before the range, the stop value. So 0 inclusive to the stop value exclusive, always incrementing by 1. So it's going to go 0, 1, 2, and then let's say your stop value is 3. It's going to go 0, 1, 2, and then it's going to stop. If we put 2 things in, then we could set a start value and a stop value. So let's say our start value is 3, our stop value is 10. It's going to go 3, 4, 5, 6, 7, 8, 9, and then it's going to stop. And then we have our statement. And then if we put 3, we have our start, stop, and then our step. Before, for these past 2, we've always been incrementing by 1, but for this one, it's going to increment by however many our step value is. We could actually just look at our examples down here. So I'll just run this. The print statement just is basically just this copied but moved up. So I in range 6, I is going to start out as 0, and then it's going to increase by 1 until we get to 6, but it's going to stop before we get to 6. There's 0, 1, 2, 3, 4, 5. For this one, we have I in range 2 to 6, so it's going to start at 2 and then stop right before 6. And then I in range 1, 6, 2 just means we're going to start at 1, and then we're going to increment by 2, so 1, and then 3, and then 5, and then once we get to 7, 7 is greater than 6, so we're going to stop right there. And so that's all we're going to be learning in terms of Python right now. We might be learning a bit more later. And I know this is a lot, so if you have any questions, be sure to reach out to me, or even try Googling your question, because there's tons of Python tutorials out there. And most importantly, tinker around with your own code. Definitely try it, and try combining everything you've learned into a single program. I could give you some exercises for that if you want. It's a pretty fun process. And so before we jump into animating systems with more bodies than just two, we're going to learn something that's going to help us out a ton. I'll explain why later, but part two is basically just going to be going over this concept of lists in Python. Now, the goal of computer science fundamentally is just to optimize certain like mathematical processes that we're doing, because a computer, of course, can do math like a billion times faster than any human can. So our goal is to make our code as concise and short as possible with no repetitions at all. As a general rule, you should really have to copy and paste a segment of code multiple times. This is why we have loops, so we don't have to write the same thing 10 times if we want a loop that goes for 10 iterations. And we've already put this principle to use in something like our force of gravity function. Instead of doing this full mathematical the full mathematical calculation every single time we want to calculate the force of gravity on two objects, we just call the gravity function f sub g, and the computer does all this in the background. So this is another example of how we're not copying code. Instead, we're optimizing it to make our code more short, readable, and ultimately understandable and more efficient. So when we want to oops, sorry, I cut to the wrong slide. When we want to store multiple values in a single variable, you'll see why we'd want to do this in the next part. We can use something in Python called a list. Now, I'm just going to run through some of the syntax of it, and hopefully you could learn just by these examples. So, simply, a list is basically something that holds different items or multiple elements inside of it. So to declare a list, you're basically just going to use these square brackets and then indicate however many elements separated by commas. So in this case, I have 3 strings. I store them in the list, this list. This could be any variable. It could be x, y, potato. And then when I print it, I'm just going to get this list with all 3 elements inside of it. Now, a list doesn't have to be strings, it could be numbers, so we could do 7 plus 7 as one of the elements in the list, or it could be Boolean values, so we could do, let's say, true and false. They don't all have to be the same type, and as you can see, we get apple 14 and false. Now, so far, you might not know the benefit of one of these lists. It just stores multiple values in one thing. To access these lists, we can access them based on their index. So this, the way that this list is organized is that each of these have an index. So indexes always start at 0. So apple is going to have an index of 0. Banana is going to have an index of 1, and cherry is going to have an index of 2 in this list. And the way to access that is to just do the name of the list and then square brackets and then the numbered index of which one you want to access. So this list 0 would access apple, so it's the 0 index, and 2 would access cherry. And when we print it, we can see that should print the whole list, apple, and then cherry. Now, the cool thing about lists, in Python at least, they're similar to if you've taken AP Computer Science A. If you're taking Java, then lists are similar to array lists in that they're changeable, they're mutable, as you would say. What you could do is that you could add things onto the end of the list, and that's what this .append function is going to do. It's going to take this list and it's going to add another item onto the end of it. So before we just have this list with 3 items, index 0, 1, 2. When we append orange, it's going to put a new one, orange, at the end of it, and that's going to have the 3rd index. So what we predict should print when we run this function is first the list with its 3 components. Then we append. This isn't going to print anything. This is just going to change the value of this list to have 4 values now, and orange at the end. When we print it again, it should print the version of the list with 4 values. And then 0 should access apple, and 3 should be 0, 1, 2, 3. It should print orange. And when we run this program, we see that that's what we end up seeing. The one with orange added, 0th index, and then 3rd index. Now that's basically how to declare and add items to lists. One of the other strengths to using a list is when we loop over them, it's a bit easier. So if we wanted to loop over a list, this is a new type of loop that we haven't learned yet. It's called a for each loop. And I'll just talk through roughly what it means. So what this is going to do for x in this list, you can think of it as for each item, which we're going to denote as x in this list, and then we're going to print that item in this list. So just to show you what ends up printing, it should print every single item, this apple, banana, cherry. And so uh, yeah, every variable for every iteration of the loop, it's going to assign whatever index or whatever that iteration of the list indexes to x. And so yeah, I hope you understand what I'm saying. This is a lot hard to explain. Yeah, again, you'll see that these three items are printed, and if we add more, then it's going to iterate over that too. If we want to add another thing, like hello at the end, just to see what happens, then we'd see that it should print hello at the end of everyone, at the end of all of them. And I've just gone over very quickly and very simply a couple of features of lists, but lists have a ton of other really, really cool features. I'll link a resource below so you could explore with some more examples, but all we need for the purposes of this so far is just how to declare a list, how to append values, and looping over them. And so just as a bit of review, lists can contain any combination of data types. To instantiate them, you're going to use these square brackets. Indexes or lists have indexes that always start at 0, and to access it, you're going to use the name of the list, and then in square brackets, the index that you want to access. You can add items to the end of a list with the dot append, and then you could access those with another index. And you can loop over all the items on a list with a for x in. You could change x to for all items or for all potatoes in this list, and then you could do whatever you want with it. In this case, we're printing it.